Today we're going to be focusing on independent and dependent variables. This is going to go in your expressions and equations section of your 5-subject notebook, continuing on what we just learned with inequalities. As you can see here, these are some of the keywords we're going to be working with today. Table, linear, changes, proportional, x and y, graph, and depending on. Now let's start with a little bit of vocabulary. Go ahead and copy this down your 5-subject notebook. You can go ahead and pause the video. So let me read this out to you. The independent variable is the variable that can be changed. The dependent variable is the variable that is affected by the change in the independent variable. So in short, think about what independent means. Independent means by itself, on your own, can change whatever. Now, when you think of the word dependent, look at the key word depend. When you're depending on something or someone, you're relying on them. In this case, the dependent variable is the variable that changes based on the independent variable. So whatever happens to the independent, whatever happens to the dependent, comes from the changes in the independent. Go ahead and write this down as well. Independent variables can be represented by various letters. The most common one is X. It could be H, it could be Z, it could be a star, it could be a heart, anything. But the most commonly used is X. Now for the dependent variable, the most commonly used is Y. But again, it could be any letter or symbol. Always and forever, this is important. Y depends on X. It's the same thing like I said with the dependent variable depends on the independent variable. Y depends on X. Go ahead and pause the video and you can write this down. Now, how we see independent and dependent variables, they're going to be represented in a relationship that is in a table, an equation, and or graph. Go ahead and write that down as well. You can pause the video. Go ahead and copy this problem down. On a math quiz, you earn 4 points for each question you answer correctly. There's going to be a table below where Q represents the number of questions that you answer correctly on the quiz, while P represents the total number of points that you score on the math quiz. So again, it doesn't tell us X and Y. It could be any kind of variables working with independent, dependent, but it depends on the situation. In this case, we're talking about questions and points on a quiz. Go ahead and write this down. Go ahead and copy this table down as well, where we have Q and P written. Now, let's think about this problem again. Q represents the number of questions that you answer correctly on the quiz. P represents the total number of points that you score on the math quiz. So let's think of what would be our independent and dependent variable. So look at P. When you're thinking about taking a quiz, you want to get the best grade possible. But the number of points and grades you get on a quiz depends on, well, how many questions you got right. So in this case, your independent variable would be Q. So write this down. Independent variable that would be your Q. Now, your dependent variable will be your P. And we see that the more questions you have correct, the better your points are going to be. So your independent variable is Q, the number of questions you answer correctly, and P represents the total number of points that you score based on the questions you got right. See how P relies on Q to work. So once again, your independent is Q and your dependent variable is P. Go ahead and write this down in your notebook. You can pause the video. Let's look at the equation that goes along with our table. We have P equals 4Q, where once again, P is our total number of points we receive on the math quiz. So our points equals 4Q, where Q is the number of questions we answer correct. Now, let's go back up here. 4 here represents 4 points for each question. Look at the keyword each. That goes with our keyword going with multiplication. So 4 and Q, their relationship is being multiplied, where there's 4 points for each question I got right. So let's plug in some values here. So let's say I plug in 0 for P and I get Q. So what's going to happen is that if I answered 0 questions correct, I'm going to get 0 points. And if we plug in P 0 and we plug in Q for 0, if I get 0 questions correct, 0 times 4 gives me 0. Now go ahead, what if I put in 1 for Q? If I put in 1 for Q, write this down. So if I put P equals, now we have 4 points for 1 question I got right. That will let us know that my P would now equal 4. So see how when we plugged in Q, we got P being 4 based on this equation here. And it's the same thing that if I did 2 plugging in and getting 8 as my answer, because 4 times 2 is 8. This is how an equation would work with your table, where again, your points depends on how many questions you get right. And there's 4 points for each question. So go ahead and write this example down too, to see how each value would plug in. I'm going to go ahead and pause the video. So we've had our table, we've had our equation, now it's time to graph it. So based on the table that we have here, we're going to plot that data down. Now I want you to cover this graph. Let me take this out. I want you to copy this graph down. It could be a little mini graph on your notes. Now, where you have the number of questions correct right here on the x-axis and the total number of points on the y-axis. Now remember what the number of questions correct would be. That would be your independent variable. And your independent variable is Q. Now, independent variable is always on the x-axis. Independent variable is right here. Now for the dependent variable, which is the total number of points, which is your P, that is going to be always on the x-axis. So remember, horizontal, your x-axis, is going to be your independent variable, and then your dependent variable is always going to be the y-axis. So go ahead and copy this graph down, pause the video, and we'll go ahead and plot these points down. So now we're going to go ahead and plot this data, where if you think about it, this could be x and this could be y. So your x-axis, your 0, is going to be 0, 0. Now, that sounds familiar. My coordinate is going to be 0, 0. So my coordinate is 0, 0. That's also my x and my y, or in this case, Q and P. So we're going to plot this on 0, 0. So go ahead and do that with me. So right here at 0, 0. All right, now we have another coordinate. It's telling us 1 and 4. So write these coordinates down too. So now I have 1 and 4. So with my x being 1 and my 4 being my y. So this would look like 1 to 4. Now, let's look at the rest. We have 2, 8, and 3, 12. So go ahead and make coordinates out of that. So it'd be 2, 8, and then 3, 12. So our graph is a little too small. That's okay. Just know that this would be 312. Now, what do you notice here? This graph is what we call linear. Linear. So this graph is linear. It's going in what we would call a line. Look at the first part of this word, linear, line. This lets us know that we have a correct graph. Now, this lets us know that it is proportional. So a linear graph equals proportional. Now, when we have a linear graph, it tells us it's proportional. What that means is that our x and our y match up. They make sense. So if what wouldn't make sense, what wouldn't be a proportional graph, if this right here was over here, and this is over here, and this is over here, well, that's not accurate because it's all over the place. And that's not a linear graph. This does not accurately tell us if we have a good independent or dependent variable. This does not make sense. All right. So what we had before, this would be a linear graph, a proportional graph, a correct representation of independent and dependent variable. So if you see this linear line going here, that lets us know it is accurate. All right, so go ahead, and if you haven't already, plot this down. Now, just a little bit of overview. I gave you this half sheet. Fill in the blank. Some of the stuff you already know. So we know that a variable is a symbol, usually a letter, that represents a number. In the expression 2a minus 5, we know that, we know that a is the variable. In the equation 15 equals 3d, d is the variable. So go ahead and fill this in as I'm going through. So we describe how two quantities are related using variables. We know this. Now, once again, two kinds of variables, independent and dependent. The independent variable, oops, switch this up. The dependent variable depends on the independent variable. All right. Now, for example, I have the total cost T of hamburgers, which cost $1.95 each. Depends on the number of hamburgers to be bought. So in this case, our independent variable would be H, or the number of hamburgers. Now, our dependent variable, what depends on the number of hamburgers that need to be bought, depends on the total cost. So if you think about it, when you're buying these hamburgers, the total cost of how much you're going to pay depends on how many you're going to buy. All right, so the total cost depends on the number of hamburgers we're buying. So moving on to the next problem. It says Coach Tally will buy basketball shoes for each person on the team. Each pair of shoes costs $98. The directions are saying to write an equation showing the relationship between the number of players and the total cost to be spent on the team. So first thing is first, you have to define your variables. Now, variables can be whichever letters you want, as long as you know that one of the variables is going to give you the number of players and the other variable is going to give you the total cost. So I am just thinking number n, letter n for the variable to represent the number of players. You can choose whatever you want, but in this case, I want to choose n. And my total cost will be C for cost. Now we got that down. So go ahead and keep filling these in. Now identifying the independent variable and the dependent variable. So in this case, we'll think about it. Basketball shoes and how much each is going to happen here. So wouldn't the total cost of the shoes depend on how many players he has to buy for? So think of independent and dependent here. So pause the video and what would you think would be the independent variable and the dependent variable? And then we'll get back to it. Now, you should have answered that the independent variable is n and the dependent variable would be c. So your independent variable, the number of players, that would correlate with the dependent variable, the cost. The cost of all the shoes would depend on how many players there are on the team. So the next step is writing an equation for this situation. So we know that the dependent variable is C, the total cost, and we know the independent variable is the number of players. This would be represented as C equals 98N, where the total cost would equal $98 shoes per each player. Now we have our equation. Now with any equation, say I'm finding the total cost of buying shoes for 15 basketball players. So what do you think we have to do? We have 15 basketball players. We're plugging in 15 with n, the number of players. In this case, we have 15. So go ahead and you can solve this without me guiding you. So I'm going to pause the video and you come back to me. Now, what should have happened here is that we're plugging in 15. We plug that in. Now, whenever you see this right here, 98 attached to the end, a coefficient on the variable, you know the operation is multiplication. And that's the same thing here. So we're doing 98 times 15. So $98 for 15 players is going to give us 1,470. And in this situation, C represents the cost. So it's $1,470. So if you haven't already written this down, go ahead. I'll pause the video. Now I also gave you another half sheet. I want you to do this on your own, but we'll read this out loud together. The Hamburger Hut charges $2.50 for each hamburger. Mrs. Shannon's 6th grade class will eat lunch at the Hamburger Hut next week. Fill in the table to show the total cost for the number of hamburgers in the table. So let's look at this really quick. The number of hamburgers, H, and the total cost. We see that one hamburger is going to give us $2.50. And 2 hamburgers would give us $5. So go ahead and pause the video and fill these in, and we'll get back to it. So this should be your table. Now, whoopsies. Let me undo that. Now, we have our table here. Now, down here, so you don't get confused, we're saying the number of hamburgers represented as n. So it could be 50, 75, 85, any other number. We would plug in any of those numbers with n. So the total cost would be $2.50 times any number. So n could be any number. It's just letting you know you can go on to like infinity. So don't get confused on that. That's just letting you know that it could be any number. So let's go ahead and look at this table right here. And then you give me the equation that would go with. So looking at the table and looking our past notes, what would this equation be? So go ahead and pause the video and we'll get back. So our equation should look like this. Go ahead and think about what our independent and independent variable would be. So would the cost depend on how many hamburgers I would buy? Yeah. So this translates into the equation. So when I have 2 hamburgers, I'm going to plug in the 2 hamburgers. If I plug in 2 hamburgers, multiply that there is $2.50 per hamburger, I'm going to get the total cost of 5. Now, when looking at your equation, you can test this out by plugging each value in. So our equation should be C equals $2.50 times n. And remember that this here, when they're stuck together, that lets us know it's a multiplication. So go ahead on your half sheet and graph this. So I want you to graph the first 6 entries in the table above. So the first 6 that we have here, I want you to graph it on the half sheet I provided for you. Once again, they remind us that the independent variable is graphed on the horizontal axis, or in this case, the x-axis, and the dependent variable is on the vertical axis, or the x-axis. So right here, they already gave it for you. What I want you to do is do this y for the y-axis and x for the x-axis. And so we know our x-axis, the independent variable is the number of hamburgers, and the total cost is, and the y-axis, the total cost would be for that problem. So go ahead and graph this and pause the video and we will get back to it. So your graph should look like mine. Now, if you're wondering, how in the world am I going to plot $2.50 when they just give me whole numbers? Now, think of it like this. Our first coordinate is 1 and 250. Now we have 1 on the x-axis, and then we have 250. Now, if this is 0, this is 1, 2, and half of that right here would be the 2.5, and then 3, 4, 4.5, 5. You see where I'm going with this? Now let me undo that. So that's how you would plot it. So once again, this is a linear graph. This lets us know that this is the right data. This is what it's supposed to look like for an independent and dependent relationship, a linear graph, a proportional graph. All right, so if your graph does not look like mine, change it. Okay, so here we go. Now, next up, it says the graph shows the distance Marla walked in a certain amount of time. So in this case, they give us the graph. Now, in this case, make a table of values for the data in the graph. So based on this graph, you can pause the video, look at this graph, and then based on the information, knowing that this is our x-axis, or independent variable, and this is our y-axis, or dependent variable, go ahead and plug these values in. And so once you plug those values in, go ahead and answer these questions while you're at it. And then when you're done, you can come back and I'll let you know the answers. All right, go ahead. So your information should look like mine, where I plugged in the coordinates in my table, 0, 0, 1, 200, 2, 400, and so on and so forth. And I wrote my equation like this. Now, if I plugged in 0 for my time, no time, and I plugged that in for 200, 0 times 200 will give me a distance of 0 feet. So if I plugged in 200, if I plugged in 1 for my time, 1 minute, 200 times 1 would give me 200 feet for distance. Now, when it's asking what distance could Marla walk in 12 minutes, I went ahead and plugged that in and got 2,400 feet. And I did the same thing for 4.5 feet and I got 900 feet. So if yours does not look like mine, go ahead and change it. Now, the checkpoint for the day is I want you to solve these on a sheet of paper and turn them in to me when you're done so I can check your work. Now, go ahead and pause the video. And when you're done with this, go ahead and check in with me. All right.